Hi guys, I hope you're good since last video. This is one of those that could be done in 3 different ones, but I put all in one for my thought process to follow nicely to the end in a kind of a logical way. In this video we are going to see resource limits and requests, some important configs, the activation of a metrics server, and more, working at different levels, container level, pod level, namespace level. Be ready, as it will be quite interesting. So chill and open Kubernetes documentation, your terminal, and play with your cluster with me, going back and forth with documentation, pausing the video. I've left a link in the bio for students who want to learn AI by doing, beginner devs who want to think at a different service that they could offer, or business owners who want to use AI for themselves. It is free. There is a guide PDF to download and the video. Link is in the pinned comment and the video description. Get it now from our hub. Check our houses. Also, please like and subscribe. Thank you for your support. Open your terminal. Let's get started. Get metrics server running on the cluster. So we're gonna go on GitHub. That's where you start this video by doing a little installation. Okay, metrics server, Kubernetes, SIG. So that's the repository. And here you will see that there's the metrics server available. There should be just one command to run to get it. Those different versions and the metrics server matching version. Okay. So here we are still in the cluster 1.28 version. So we're going to use one of those two here, the manifest. Okay, high availability. And you get more details. And there's also an Helm chart if you prefer to use a Helm chart for that. But we are going to use just the kubectl apply and get this from the repository directly. So we're just going to go with this installation. Okay, so you just copy and you apply this to your cluster in your terminal. We will need that just to have some checks. The video is going to be lasting for a certain time, so we want to be able to see those metrics sometimes just to check. It's not perfect, but at least we get something to see and to know how much resources are being consumed. You can also use wget if you want to keep it for yourself in your environment. So that's what I did here. So I have it on the side already. And that's the file. So there's a cluster role, okay, to be able to read those resources. So resources, pod, nodes, you can get list and watch. That means you can read those. Cluster role binding, so some RBACs. The service, there is the main deployment after that. So it's using HTTPS. Okay. Same here for the HTTPS. There's a little trick, because when you're going to apply this, not sure that it's going to work, because we're using self-signed certificates, so they won't be trusted directly. So let me just get pods, that's all the pods that you have running in our cluster. So the cluster is empty. We just get those kube systems on the storage one, local path, apply it, all those resources. So now we get that metrics server that should be running, but I want you to see the different parts and what can go wrong and what you need to do to prevent that. So the service is running, but you see here the pod metrics server is in a running state, but is not ready. It's on 0, 1. So we are going to see here that still it's on 0.1 and it's never going to be actually running 100%. I'm going to describe it for you. So you're going to see here readiness probed, HTTP, status code failed 500. Okay, so it's never going to be ready. It's unhealthy. We get a warning for that. So this is because of the TLS certificates. So you just need to enter this command to patch the metric server. Okay, and you're going to be using the flag kubelet insecure TLS, so that is going to accept those self-signed certificates. And now you see container creating. We have 2 of those. So it's going to be created and replacing the other one, which is not working well. So we just wait. So you wait a bit. We're going to wait together. It's not going to last long. Let's get the pods. This was the command. Okay. Still waiting. It's almost there because it's in a running state now. And after one is going to replace the other. The new one is going to replace the older one. So part of those resources, we got also the deployment metric server. Okay, and now it's available. And we can also describe this deployment, which is called metric server. Okay, so you see here how it has scaled down and scaled up the new one, or scale it down the one that didn't work. And here you can see the flag kubelet insecure TLS. Okay, so we have patched the deployment. Okay, not the pod, the deployment, which has created a new pod, and now everything is running. So now that we have the metric server running in our cluster, it's not going to take a lot of resources, but we will be able to check how much resources have been consumed or how much resources are available in our cluster. So you can use now the command k or kubectl top command, like the Linux top command. And here you can see the CPUs used and the memory used. Okay. So for the nodes also we can do it, and we will see that there are some different percentages telling us if it is having some resources left or not. Limits, request, resource for efficiency. So is using very low requests and limits can actually be efficient for your deployment or pod to work fine using less resources. So we're going to create here a pod called Meidaimai, which is a neighbor very close to Shibuya, a few stations away. So we're going to be still staying in those Japanese neighbors, and we're going to call it Meidaimai controller resources. Okay, so at Meidaimai you need to control the resources, and in this location here we're just going to clean up a little bit just to make it as clear as possible to read, because we don't need all the different strategies and everything. We just make it simple. I like to have the name on top here, and after just to put the image after, but you can keep it as it is. So what we are going to do here, we're going to play with this pod. It's very important to start with this. Here I just change the label, And after, we're going to be limiting the resources. So in the resources, there are requests. There are also limits. And that's what we're going to see. So first, let's attach a volume to this pod. So we go volume mount. The name I'm going to use, let's call it, just wait. So resources is going to be here at this level. So I'm just trying to simplify. So I don't put the volume yet. I just put the resources. Requests, you can request memory and CPU. You can request more, but we're going to see it later. Just here, let's focus on memory and CPU. Okay, so this is kind of a boilerplate. I request 16 MI of memory and the CPU 250 milli. So I'm going to talk about those also. Those units that are used for CPU and memory and the different ways that you can write those. Okay. And the limits, so the maximum that is available, that is able to actually consume, will be 32 MI for memory and 500 M for CPU, which is a half a core CPU. So minimal way to control resources at container level. So let's just bring it down now to something very small. 2 KI memory and the maximum 10 KI for the limit. I'm just working on the memory. So you see I just bring it to very low levels. Let's see what's gonna happen. I'm just gonna be here putting a namespace. It's not you don't have to do that, but here just for the example, I'm going to put it in a namespace. If you don't put any namespace, it's going to go anyway in a namespace, which is called the default namespace. And the namespace is going to be called controlled resources. Okay, do some name change, controlled resources. That's how I'm going to call it. And we might need to actually check if you have the namespace available now. So let's create the namespace that you have just designated in this YAML file called controlled resources. So we have created the namespace. So now we are ready to apply this pod to the cluster, to run it there. Let's deploy it. It goes, it's a pod, should be running. That's what we expect. There's no issues, and we are very conscious, so we put some limits on the resources that it can consume, which is very good to do, good practice. But let's see, is it gonna run? Made my control resources, status container creating, status container creating, you know Nginx. You know that it runs almost instantly. So why is it not running? So let's do the description of this pod just to see the details of it. It's in the namespace control resources, and we have a nice big message here. See, I just printed twice, but you see, there's a lot of events that happen. Control resources made node 2. And after here, you need to read that message. Okay. OCI runtime runc, created, failed, unable to start container process, unable to apply C group configurations, unable to start the container. You see, CRI container D, because I'm using container D. And runc is the container runtime, the interface. So here, the container runtime, okay, the runc, I mean the container D, let's call it container D, using runc, so that's the default for container D, is not able to start the container. So resources are not only the container that you are going to run. The container runtime itself also is consuming some resources. So here as the resources are too low, so the request limits that we have put in place, which gives a range. Here, it's more the requests, as we don't have enough. So we didn't provide enough resources in the YAML file. The limits and the request that you have put is not even enough to start the container. Okay? So the runtime itself doesn't have enough resource to do his job, which is starting the container. So this pod is never going to run. Okay, the container runtime runc also needs a bit of resources. Okay, so we need to increase it. So it's not easy to know how much you need to put in terms of resources, requests. It comes with experience. After, I'm going to try to show you a way that you could use. Very easy, but doesn't work every time. But we're going to see if it works with my cluster. The best way to check how much resource you would need is to use Ktop. So that's why we have installed this metric server while running a test workload, a test pod with one container. So that's what I suggest you to do. Maybe you just create a container, you let it run for some time. If you have Prometheus and Grafana getting those metrics, you can get a graph and just see. So you can see how much that container needs. Okay, so you don't put any limits, let it run, see how much it needs, and from that you can create your standard in terms of resource requests and limits. So here we are not going to be going to the big installations. So use testpod to see how much you need. That's what we're going to use. I'm not going to install Prometheus and Grafana. So I'm just going to delete this pod. Okay. And we're going to run the test pod directly into the cluster using the same image, Nginx. Okay, not a boilerplate this time. We just run it straight. We see it's container creating, and it should be running very quickly. Let's wait a few seconds more. Okay, it's running. Okay, now we can do Ktop pod. So the pod here is called test pod. Okay, this one. And we can see here 9M for CPUs and 3MI for memory. We will put kilo when here it's mega that we need, at least 3. So after you can't rely really on this number, because here I'm just using a simple metric server. This might change, and you need to do it for a longer period, have a graph and see. That's why Prometheus and Grafana is the best to do that. So maybe also you need to add 20% on top of those numbers to have a minimal resource request at least. Just some contingencies around your strategies of deployment and limits. So that's what we would use. So let's go in. I'm just going to make it larger. I'm not going to do the 20% of 9M, 20% of what we've seen. I'll just put it a bit larger. So we needed 3 mega, I just put 16 mega. And put a memory here of 32. Just to show you that it's gonna work if you give it enough in terms of requests and limits. Resources, if you declare it the right way, the runtime will be able to do his job, and the pod will be able, the container in the pod will be able to start. And now you see it's running after 10 seconds, even quicker. Okay, let's do a top on this pod just to see what it says. Okay, 16M and 13 mega. So it's using a lot actually. Resource limits requests. Volume issues. So we're gonna use this story, work around this volume issue to master those controls of resources, limits and requests. So in the previous videos, we've been using, for example, the one that we did, init containers and the sidecar containers. We had 2 different containers in the same pod sharing the same volumes, and those volumes, that's what we're going to use here. But the way we did it is because we're not focused on the volumes. We were focused on init container, that was the subject of the video. But here we're going to focus on those volumes because there is an issue in setting those that way. So in different tutorials, you're going to see people using it this way, but you can't use it that way when you're working in a company. And we're going to see why and how we can use those requests and limits to control this issue. So the volume mount here, we're going to create one called special shared volumes. The mount path is in the TMP cache. After we get the volumes at the same level as the containers. On inside, we have the name, which is special shared volumes, and empty dir. That's where there is an issue, is with using empty dir this way. So here we can comment. We are going to play with this to understand why resource control is important. Okay, so we'll just keep going in making this YAML file. So what we can do, we can maybe have a sidecar container sharing the same lifetime with the pod. So we're going to put it on the containers and we're going to add another container. So let's use sidecar container with the same lifetime as the pod. So if you haven't seen the video where we've done sidecar container, please go back into the playlist and check out the sidecar containers. So here I'm just going to change the name, made-by reader, and I'm going to create here a container made-by writer. Okay, this is going to be writing into the volume, that's the share together, and the other one is going to be reading that volume. Because when I'm going to exec into this pod, I'm going to enter into this pod the order of containers that I put here. So the one in first is made by my reader. So that's the one by default in which we're going to be entering in. We're going to use BusyBox 1.36.1, the version. We're going to use a shell command with some arguments, with the option C, like if you were in the terminal writing it. And after we're going to just write a sentence in a file. So I invite you to go and see that video about sidecar containers, just to understand what we're doing. And also in that video I show you how you can activate the feature gate, so called sidecar containers equal to true, for you to be able to use sidecar containers in your cluster, especially the init containers also. So here we're just going to put a sentence, Rigoletto Italian restaurant in Roppongi Hills Tower this Thursday at 6 p.m. Okay, so that's a very good restaurant in the iconic Roppongi Hills Tower of Tokyo. So here I'm going to put it TMP cache, that's where the volume is, and inside that volume we're going to create a file called whichrestaurant.txt, and we're going to sleep for, I don't know, 10 minutes, something like that, just to have it for the example. Okay, should be fine here. We have one made-by reader, we have another made-by writer, two different pods. We just need now to have the volume mounted into also this made-by writer. We are done with the arguments. And it will be the same. I could have copied. So volumes, special shared volumes. And after we go for the mount pass TMP cache. Okay, I think we're all set for this example, and down there we have the volume. Just let me here want to put a comment here. So we can also have some limits in that made-by writer container. So let's use resources, requests, memory, CPU. So it's good that you do this YAML file with me, because this YAML file is going to be evolving, and we're going to be playing with this YAML file a lot in order to understand all those different mechanisms of resource limitations. Okay? So let's play with the indentation, put it back here. So we're going to give it 1 MI for the memory, 500 CPU, which is a lot. It's too much for BusyBox, but it's okay. It's just an example so that you can see different notations, because I want to use CPU with just an integer without any unit, because later on I'll be explaining you about those units, so that here you've seen different ways, which is going to bring some questions to your mind that we are going to have to fix with a clear explanation. Okay, so we follow the same schema here. We got the name, the image, we got the resource, and we got the volume mount. So here I can say memory binary base, just to give you some hint in those notations. Okay, let me put it here. Memory binary based notation. Okay, there'll be more and more comments coming into this file, but it's a good way to have a documentation, have the comments straight away into the code. And this one, memory decimal based notation. Okay, so for the, I put memory, but I'm going to show you how to write it, but I'm going to comment it out, okay? Because there's different ways that you could have written that. We have 3MI or 3M, but if you write 3M, it's not the same as 3MI. 3M is like 1000, 2000, 3000, okay? That's why you have M, mega, for the bytes. It's byte is the base unit. And while MI is not 1000, 2000, it's 1024, 2048, and after it's going to go like that. And the scientific based, purely numeric, so good if you're using a script, templates for code. Let's say you want to be creating that using some templating tools. You have your own code base, you want to create your own custom stuff. You can use this scientific base way of writing it. So we don't need here to specify M or MI. We just put a number, but we tell how many zeros there are behind that number. Okay? So 3 is 6. You're just going to go E6 and you're going to increase whatever it's in front. So here will be like 3000 bytes for that. Okay, we can save this. I bring it slowly. Those are a way of seeing those units, but I have a part especially for that. Made IMI reader, request and limits, on CPU and memories, sharing a volume with the other container, which is made IMI writer, okay, and they're using mtdir. Mtdir, using it is an issue, and you will see why. And here same, we have a memory and request on made IMI writer. Okay, it's good to see it slowly like that. And after we apply this to the cluster, okay, there is a typo, spec volume names. Okay, it's spec volume name. I think there's no S. I just use nano here. Let's go down. Where is it? Here. And name. That's good. Let's apply. So I get some bugs with the terminal on NeoVim sometimes. So I need to clear the page very often. So get the pods. It's running. How to find and track the volume. Let's go step by step before revealing the big issue about MTDR. Here you just get the pod all wide, so you see in which node it is scheduled. Scheduler has decided to put it on node 2. We're going to do an SSH on node 2. You remember it was TMP cache. We go in TMP cache, but you will see it's not here. There's nothing in TMP cache because that's not the place where you find the volume. So in some previous videos, that's where we found it because we used local option. That's why it was on the node, but here, no, it's not here, especially when you use the storage in the storage video. That's how it was. So you need to go in the kubelet folder. In the kubelet folder, var lib kubelet, you get the pods. But let's say you have 1,000 pods. You're gonna get here 1,000 of those different numbers, codes, so you don't know which pod it is. I'm gonna tell you also how you can find the right pod. We need to get the pod UID. So we need to go back to the controller, find the pod UID. So let's go back to the controller for that. So I'm just gonna exit this SSH connection. So get the pod UID to find the volume. So we get the pods. We're on the controller node now. Here, okay, get pods. And the namespace is control resources. It's JSON path. It's in the metadata. So we need just to fetch it from the metadata. And it's going to tell us. So I need to indicate the pod, 100%. What's the name of the pod? It's made by my controlled resources. Oh. So output JSON path. We want to have an output of which field of metadata.uid. Okay, there is an issue. So it's not JSON path with a capital P, it's a lowercase p. And here you see we get the number here, CEC5F. You can see it here, that's the same number. And that's how you know which pod you can explore. After, I'm going to show you also another way to get this UID in a nicer way. So you can use custom columns. That's an option. And after here, you do your own custom columns. So we can use the pod name. So what I'm using here, it's arbitrary. That's why I'm using pod name, just to show you that it's arbitrary, the key, but the value is not arbitrary. We want metadata.name. It's going to be fetching that. I'm going to put it in a table, kind of a table way. And here same, the pod IDU. I do it on purpose, just to show you that this name is not mandatory. It's just I put a name for that. Any name you can put, and you put metadata UID, and here you can see you get the pod name, name, and IDU. Okay, we're done with this. Now you know how to get the pod ID. Now that we got the pod ID, we can go and see where is this volume located in the node 2. So let's SSH back into node 2. We're in the pods. Is this one? So we can copy it. We know that it's this one. Okay, not this. So I need to yank. I can't use Shift Control C. Okay, same. Doesn't work. Just give me a second. I'll be able to copy this. Okay, now I've seen the confirmation that it's been copied. And now we go in. And you see you have more. And here you can see volumes. You go inside volumes. You can see mtdir. Kubernetes IO mtdir. .io-mtdir. Okay, it's not a dash, it's a tilde. It's Kubernetes IO. It looks like a dash, but it's a tilde. So kubernetes.io tilde mt-dir. So you can just use a copy and paste if you want, but here is a tilde in between. That's why we get this error, and we're going to change it for shift. Okay, and now you can see special shared volumes. The one that you have created in the container has a shared volume, and we get our file inside which restaurant. Okay, just to keep going the learning, because we've seen storage, we've seen volumes and everything. At least here you know where it is, and also we need to know where it is, because we're gonna just check what's the issue with that. And we get a sentence: Rigoletto Italian restaurant in Roppongi Hills this Thursday at 6 p.m. So let's use the same command here, but just for the folder. We're going to use the du just to see what's the size of this file. It's 8. It's very, very small. Okay, so if it is 3 numbers, it will be 1000, which is going to be 1 mega. Here is just 8 bytes. Now let's go inside the pod and make this increase, okay? And see if it respects our limits. So we have set limits of how much resources can be used. Let's see if it's going to be respecting those limits. So we exit, we are back into the controller node. We can see the limit in memory here is 32 mega. This is for the made-my reader, and for the writer we have a memory limit of 3. Okay, so for the pod, you are just combining both, we would say it's like 35. So let's put stress on the memory. So normally here, because we're entering in 1, it will be 32 the limits, because we're entering into the container, which is going to be the one that we have selected first. So I'm going to do an kubectl exec it, and I'm going to be inside of it. So now we are inside. We get the sentence telling us default container made-my reader. So out of those 2, because it's the first one, I'm going to use the command, go into this temp cache volume. Okay, if def 0 of made-my txt. So after here you can put any file. You just create a file and you give it a size. And in this file there will be zeros written, a lot of zeros, taking a size of 20 mega, count 1. We just multiply it by 3. Let's go 3. So we do that and it will be 63 mega, 60 MIB. You see? It's not 60,000, it's a little bit more because it's MIBs. But you see here, the 556,000 bytes, which is 61, I said 61M, but it's 61. It is 60 MIB or 63 MB. It's bigger than 32. Okay? That we have set as a limit is even bigger than 35, combining both containers. But we get it still running, no problem. We're gonna exit. We're gonna get the pods all wide. Okay, so it's still running, just to show you the state of it. There's no issues. So why our limits haven't been enforced by the cluster? Let's do a top pod and see how much is using in terms of resources. It says 4 MI here. So here it considers that it's not consuming that much resource, while we have increased it to 60,000. So let me SSH in this node 2 the right way. Let's go and see that volume. What's the size of it now? It's 61,476. It was just 8 before. So do you get what's the issue with that? This volume present on node 2 can just go basic and consume as much resources as it wants. It's not tracked. It's not enforced by the limit requests. The requests and limits range that we give to the pod and the different containers. Here, you got the example of importance of resource control with limits, but MTDR has no limits, is unlimited. Okay? So this consumption of resources on the disk that you don't see, and you might get some issues with that. So limits request is just for the pod consumption, but volumes need to be addressed also. So we're going to see limits and requests of volumes. So otherwise, the node could run out of memory. And you see, when it's run out of memory, it's going to start evicting those pods. Okay? So here it's a kind of a disk memory, because we give it a path. But we will see later on there is a little option that you can add if you want to use the in-memory memory. So to have it just on the fly, created in the memory. So one pod will be evicted, putting more loads on other available nodes. The scheduler is going to try to schedule those pods somewhere else. Please like and subscribe. Just having a little break. And we're going to pass to the next topic. How to limit control MTDR. That we've seen that issue. Let's go and try to provide this contingency, trying to limit this MTDR volume. It's very handy to use, but you need to control how much it will consume in terms of resources. You don't want it to be taking more resources than what you want, and you want to also have an eye on how much it's going to be using. You have a huge cluster, you have thousands of pods, you have, hundreds of MTDRs. At this time, you need to have more control You can't just let it go like that. Otherwise you're going to get some troubles, for sure. Okay, so let's work on those. And now go into the MediaMy reader. And we're going to add another resource that can be tracked, that can be requested and limited. So mtdir is part of what is called, in terms of resource, Ephemeral-Storage. Okay, so it's not underscore. I put underscore here as a dash in between. So let's use that to control its max size. Okay, we're going to control its size. I'm going to use in the requests side and in the limits side. So ephemeral-storage, not underscore. And this ephemeral storage, it's using same notations as the memory. Here I'm just using the decimal notation. I put 1M, which is 1000 bytes. And for the limit, we're going to go 3M. Okay. Now we got that limitation on this container. We got the volume mount. We got the second container MediaMy writer. We're not going to overcomplicate. We got our volume here, mtdir. We're not going to change it for the moment. We just want to see what's the effect of ephemeral storage on it. So as we put a limit on I don't see my cursor again. Where is it? Okay, let's use the mouse. Okay, here we go. As we put a limit on Ephemeral-Storage, now the mtdir, as we see here, now it's back. My cursor is back. Should be under control. That's what we want. But is it going to work? Let's see. Okay, this unlimited resource consumer mtdir should be under control. Yes, this way of using is just on the disk. Let's save this file. I have some notes on the side, but I'm just going to write the comments directly into the code. Let's open a terminal. We redeploy this pod. I'm just going to SSH in node 2, so you have a well-rounded view of it, just to see that the volume has the volume we had before has disappeared, doesn't exist anymore. So it's that's why we say it's part of ephemeral storage, because It's not a long-lived storage. It's not persistent, not retained. You see, it's not here anymore. That one, we don't see it anymore. Okay? That's why it's very handy to use it. But while you're using it, you don't want to break your cluster because it's using too much resources in an unlimited way. So you want to control it. And that's why here we're using Ephemeral-Storage. So we have applied to the cluster. We're good. It's going to be running soon. Let's get the pod and see if the state is on, if there is no issues. Namespace, control resources is running. Okay, 2 and 2, so 2 containers. The prerequisite, just before that, I want to show you something because you might not be able to use Ephemeral-Storage directly, as I'm doing now. You might get some errors or like it doesn't work if you have a cluster like mine, just that you did using a kubeadm. So just before checking on the resource limits, you need to know that Ephemeral-Storage won't work unless you have some options activated on the GRUB. So I'm going to show you those options that you need to activate. That's why it's good to watch the video, every single part to the end, because if you miss one part, you'll be stuck. Okay? So for some people, for people who made it to this far, you will get those details now. So you're not watching the video jumping around, so you'll get the steps here. It's very valuable information. So 1, kernel need to be able to use cgroup v2. So you all have cgroup v1, but cgroup v2 is only available from versions above 5.8. So you tap on your terminal, you name R. I'm in a version 6.8, so I'm good. I don't need to do anything. If you are not, you need to have a kernel which is at 5.8. You just go internet search, ChatGPT, and so on until you get the right version. Then you're at the second stage. Now you have the right version. Cgroup in systemd config file need to be set to true. And then restart systemd. But this normally, when you set up your cluster at the beginning, you normally do it straight away from the beginning. But I'm going to show you here in which file you need to go. Sudo nano etcd containerd config.toml. You go down until you find the right flag. So in the plugins, there are some decorators, nested decorators. Okay, you're using containerd, systemd, cgroup equal to true. Okay, this normally you need to set it up from the beginning when you set up your cluster. But if it is not, you just go to this nested decorator, you find it there, and you set it to true. Okay, so you go down. Okay, plugin, IO container, and you find it there. Okay, and after you run this command, sudo systemctl restart containerd. Okay, so you have set it to true, you have restarted containerd, you're good with this step. There are a few steps before being able to use Ephemeral-Storage. 3. the GRUB. So we're going to open another file and add some different options that we're going to append to our environment variable, a variable. So the GRUB config needs to be explicitly having the option for cgroup v2. Okay, in one of the variable that I'm going to show you which variable. So we're going to be appending this option to it. So the GRUB, it's in etcd default GRUB. That's the one you open. You see you have a lot of variables. Some are commented out, but we're going to go into the GRUB command line Linux, CMD line Linux. Okay, so this one here. So we're going to be coming back to this one several times, but here you just need to know for this stage of the video that you need to activate it. So need to append systemd unified underscore cgroup underscore hierarchy equal to 1 activated. And this will enable the cgroup v2 at the GRUB level. Okay, to have cgroup v2 enabled and be able to use Ephemeral-Storage, Ephemeral-Storage. You have the right version. You have cgroup equal to true in containerd. And here in the GRUB, you have this option activated, appended as an argument into this variable GRUB underscore command line underscore Linux. And after that, you need to update GRUB. And you need to reboot. Okay, so here I'm not going to run it because I have already run that, already rebooted my node, controller node. So you're working on the controller. Okay, and you reboot the instance. So the GRUB option is on. The kernel version is bigger than 5.8. Yes, it is bigger and equal 5.8. So it should work. If you see 5.8, you don't need to update it. And containerd, you have enabled also the cgroup equal to true there. I mean that line that I showed you in the config.toml. Okay, so if you have all that, you're good to go to use the Ephemeral-Storage. Parenthesis closed. So this will lift away a lot of troubles that you might get. Stress memory to see how Ephemeral-Storage limits mtdir. Question mark. I put the question mark so that you watch to the end this example. because you don't know yet if it's going to work or not. So the pod is running. On the node 2, we have a new volume normally there. Okay. So before going there, let's exec. Let's put some stress on this pod. This and pass. I'm gonna get the UID. Not put some stress yet. Let's get the UID. Okay, now we can see it on the screen. Now we can exec into it and stress it a bit. We go into the volume, which is the TMP folder, cache folder. We got a little file with the sentence. So with restaurant, txt, everything is fine. Now we're going to do the same. We're going to write a lot of zeros in a file, exceed that limit that you have set. So if dev0, just create the same kind of file that we've done before. You put any name here, it's going to be okay. Made my txt bs1m count 10, so it's going to be 10 multiplied by 1m. Then in my base, so here we are 10,248. We're way above the limit that you have set. Terminated, exit. See here, command terminated with exit code 137. The pod is running. Okay. Let's try to go inside. We can't go inside anymore. Okay, connection refused. Container not found. So it says running for the pod, but actually the container is dead. We describe it. Pod ephemeral local storage users exceeded the total limit of container 3M. Okay. We want 10M. It died. Stop container. Reader. And after stop the writer. So killing, you see on the left side, the reason column, evicted, killing, exceeded gratis period, and now when we get the pod, so it takes a while, but here we can see it in the status, container status unknown. I mean, it's unknown, but we know. We did it on purpose. So that's what is good with this mechanism, is that you can have a control on how much MTDR is using. So it's not going to be consuming whatever on the node where it's scheduled. Okay, so even reapplying the same resource to the cluster, it's not going to fix it. No, it's still dead. So I'm just going to delete this pod. We don't need even to go and check this volume. We got the UID, but we don't need to do check. Okay, so that's one way. Ephemeral-Storage. Please like and subscribe during the break. Limit unlimited MTDR using size limit. It's another way. So we used Ephemeral-Storage. We have seen the different configurations that you need to have set up on your node, controller node, in order to be able to use that in your YAML files in the cluster. After that, we have seen how we could limit MTDR's volumes to not get any issues. So we're going through the example using MTDRs because it's going to help us to see different variations in how we can limit those resources and have control. Okay, so Ephemeral-Storage comprise things like images, container images, MTDR, CSI drivers. Okay, so that's what is called Ephemeral-Storage. So I'm just commenting out Ephemeral-Storage, so we're not using it anymore. And I'm going to write here, we are going to see that MTDR can be limited in another way. Using, there's no mystery, I already told you what we're going to use. So using limit directly here. So we're going to be on the volume, down there, next to MTDR. And we're going to put the limit straight away into it. Okay? Close this comment. Let's close this MTDR because I'm going to write it in the form of a dictionary this time. MTDR. And now we have a key here called size limit inside of it. And we're going to limit it to 2M. So that's another way you can limit it. But is this way going to work? We're going to see. Okay, so we have commented out. There's no Ephemeral-Storage contingency to control this limit. Now we're working on another option. We're going to apply it to the cluster. Let's see how size limits goes. So we go straight away into this pod. We exec into it. Okay. Unable to upgrade connection. What's happened? It's not yet deployed completely. I'm too quick. You can't exec straight away. You have to wait until it's in a running state. Okay, now it works. Now we are in. After, we're going to put in the same way some stress into that so I didn't CD to TMP cache, so that's why I put it here as a full path 1M, and we multiply it by 1. Okay, there's something wrong. We need the equal here. So this was the limit, 1M. But the containerd runtime is also consuming. So even using 1, we should be above that limit, you see? We're at 1M, 1MI. So we're above 1024. Let's do 3. 3080. Just keeps increasing. What's happened? We didn't get ejected. Still running. Let's describe it. Let's see if the containers has been killed. No, everything is fine. normal on the left side. I'll wait a little bit more to see if something is going to happen. It's running. We can exec into it. So that means it's still alive. There's no issues. But we have limited it using mtdir. Okay, here I did something wrong with the DU. Okay, still the same size inside. 3080. Okay, I just exit. And I go down there. I'm going to use our little commenting techniques to explain what happened. So, here we see that it is ignored. So, it has been ignored completely, this size limit 2M. So this limit can be bypassed without any problem. So we're back to our initial issue, even if you use the right option. So we need either to have a container using Ephemeral-Storage, as we've seen before, but as I've commented out Ephemeral-Storage, now we need to use another way that can use this limit. So if we had Ephemeral-Storage open up there, you can still put a size limit down there, but I don't see the purpose because you're already limiting it. So here we're going to be using a medium memory. Means that we're not using a physical path on the disk. We're going to be using a path on the memory directly, on the fly. It's going to be saving those there, but we're going to be using size limit on it so that it will be controlled. Okay, so we use the medium memory. I'm going to delete the pod that you have deployed. So that you get a well-rounded view. Here I just need to put capital M. It's memory with capital M, okay? Medium memory, size limit 2M. And now we're good to go. Let's apply this to the cluster. So to have a well-rounded view, you'll see that mtdir can be controlled with Ephemeral-Storage. And now you see that you can use also size limit, but it will be ignored. It will be ignored if you don't use any medium options, okay? After, it's up to you to go to the documentation and see more deeper into the knowledge where you can go. We go TMP cache. We're gonna run our stress on the memory command, writing some zeros in a file, making it a little bit bigger than the limit that you have set to see how it's gonna respond. Made my txt, we go for 1M. We can multiply it if you want using the count 1. So here we're above already. There's 1024, we're above that, 1028. But then we're just going to bring it to 2. Oh no, we set the limit to 2M, so we're still under. But you see here, 1956, 1956, it is throttled on the 2M, but will fail eventually. Okay? As we have exceeded that limit. Op has been terminated now. I don't know if you've seen while I was writing, terminated with exit code 137. Exited, see, it just failed. Okay, so now you can see here how this limit works. And when we describe the pod, on the left side, the reasons you can see evicted, killing, usage, mtdir, volume exceeded the limit of 2M. Okay? That's good. So you've seen the size limit of the mtdir. That's good. And now let me just comment this out. I'm going to bring it back with our Ephemeral-Storage. So I'm doing that on purpose, just to show you that you can stack many different resources into the requests and limits. We have memory, CPU, Ephemeral-Storage, and you can add some more if you want to. Please like and subscribe during the break. We're going to breathe a bit. And after we're going to go into the next step. Parentheses on huge pages. Okay, so this is another kind of resource that you can use for performance and efficiency. There is another one, but we are not going to use it, but I will show you the configs to add. I will show you how to set it up, but I'm not going to use it because I don't want the video to be 5 hours because there's a lot to see in this subject, but we're gonna just to go and see at least what needs to be set on the node, how to change it, because you got huge pages already in your Linux node, but it's set to a very small number. That's how the memory is going to be handling those writes. So writing in chunks using pages to keep track. So you need to go into the GRUB file that we've seen before, etc defo grubbed. Okay, and after you use this here, for example, and you're gonna append it to the end of the GRUB cmd line Linux variable. Okay. So huge pages in Linux are 4 kilobytes. Kilobytes. KI. So it's not a complete zero. While here we set it to 2 mega, 2 MI. So you need the Z's at the end. I thought that this was a mistake from me, but you need the little Z's at the end. So huge pages, which is Z, equal to M. And 512 is 512 multiplied by 2M. And that's how you get a lot of huge pages available. So that here your workload can use this resource called huge pages, and here you can have two different options. Huge pages 2M, that's the one we have set, but you can set it also to instead of megabytes to gigabytes. So there's another option also that you can use for that. In the GRUB, you will just change the M for G. So here I'm going to call the name, I'm going to name it my huge page. I put it here in the my writer, because when you use huge pages, I will tell you after. I just finished this. Months pass. We have another volume for it. Made huge pages. Okay, and huge pages can be also used as a medium in the volume down there. See the options that we have used just before for the memory, so you can use it also here as a medium. Okay, and here you will just come and add a new volume. This volume is linked to my huge page. And after here, we play still with the same empty dir, and you indent it and you use medium. But this time, instead of memory, huge pages. Okay. So, I put the volume down there. But here I'm just gonna show you here, because that's where I'm gonna stack all those resources, so that you see what can go with what and what can't go with what. So here I put huge pages 2 MI, 1000 MI. That's the limit I want to set. Huge pages, the S, dash 2 MI. So it can be 2 MI or 2 GI. If it is GI, so gigabytes, at this time you will need to go into the GRUB and change the settings on your node, okay? And change it to J instead of M, to G instead of M. So we can only set a limit for huge pages. So there's no requests. You can't set a request for huge pages. Okay, that's why I stuck everything here, so you can have a picture of it. I'm just going to comment it out, because we're not going to use it. But you've seen the GRUB, how to set it up. You've seen here also how you can set up a volume. But at this time you need to specify and say the medium is a huge page, huge pages. Okay, huge pages. Here I just go into the documentation. I'm also into the documentation. Use the search bar, that's the best way to use it, if you already know. And here you can see all the different comments that I showed you. Huge pages with a Z at the end. Okay. And here I'm just gonna add some comments. The docs are here. Just put it here in my comment. So I have the source of where I can find more about it. And the medium, huge pages, and the size. Okay, 1 GI, 2 MI. That's the two different ones which are accepted. Okay. And here you can see the GRUB, how to set it up. Huge pages 512. 12 is the number, so how many, that's the count. And the size is 2M, so 512 2M, which will be 1024 mega, so 1 giga one GI. Okay, and this is how you're going to set it after. You can set multiple different ones, and you can put them also together in the limits, as we've seen in the documentation. Just to make it clear, that's why I go into the documentation so you can see where it is. If you want to see more, if you want to see that more into the details. Okay. So it needs to be set. So I put 2 GI here. But, in documentation I've seen 1 GI. I don't know if there's 2 GI, but still, you just need to go through the documentation and you set up your GRUB the right way to use this this kind of customization of your Linux node, just to treat those writes in a more efficient way. So this is maybe how it is tracking. The memory is tracking where the variables are, and in between there are those pages to treat that. Okay, so for KIB, that's the default in the Linux node. So you might need to change it if you want to use huge pages. So we are done with this parenthesis. Let's have a little break and go to the next. But in the meantime, you're gonna like and subscribe if you're not already. Limit resources at admission. Limit range. Let's see that now. There's another way also you can limit resources. What about using default limits? Or just stopping everything at admission? So we're going to go slowly. See first limit range, and after see the right way to actually enforce limits on the resources at admission. So here I'm just going to create a file. And if I create it from here, so we can see how the namespaces, we still have the same configuration, the cluster. I'm going to create namespace resources limit default. Or I'm just write a sentence for my files. Default at admission setup. Okay, we have a YAML file. Now let me open it. And let's create this new kind of file that we're gonna see, which is called a limit range. And after we're gonna see what's the behavior of a limit range and how it can help you as an administrator of Kubernetes to have more control into all the defaults that you want to be set on the containers, or what you accept or not. So API version v1 metadata, we give it a name, we call it my default request limit and CPU. Request limit CPU because I'm gonna focus on CPU now. We did mtdir, we've seen the different way to control that volume in memory. We've seen how to stress the memory. So let's play here with the CPU for this part of the video until the end. Because we are approximately in the middle of the video. Yes, a little bit more, but it's okay. So the namespace controlled resources, spec limits. So we focus on CPU, but you can use this file to set up default for other resources. So in this file, I'm going to show you some example resources, but I'm going to be commenting out those example resources. And we're going to just keep the CPU, just to keep the example simple to handle. And after we're going to be just playing with that. Okay? So it can be used for any resource. So I'm just going to put the keys. We need in the spec limits default. After default, inside we need default requests. We need the maximum. We need the minimum. And the type. So the type, here we're going to be working on the container, but it can be also the pod. Okay, you need to go in the documentation and see for each type which field that you're going to need. But don't worry, we're going to see both actually in this video. You're going to be able to see container and pods. Here we just use container first until it works fine, and after we can introduce the pod in combination with container for sure. And after we just go CPU. For the resource, we're just going to be tracking CPU. But you can be going for more resources. That's why I'm going to list some here, just to show you what you could use, for example. You can use CPU, memory. Let me just put it here, CPU 500M, default requests the same, the max, we go 1, put in a string. I'm gonna be adjusting that to the example, but for the moment I just fill it like that. The minimum CPU 250M and the maximum CPU 1M. I mean one core. And the type container. Okay, so I didn't comment out anything, but you can use some other resources as a limit. Here we just focus on CPU. I just got rid of those to make it more clearer to view. Here we have a CPU limit of 1 and the request 500. This is in the writer, and in the reader we have 250M and 500M as a limit. So we might change those. I'm just going to be commenting out. So let's say they are not set on this pod. This one I keep it. I just keep the request on the writer, and I get rid of all of the other CPU request and limits. So 500, 501, 250. Let's apply this to the cluster. Okay, so I'm gonna do first this one, the limit range. What does it say? Kind not set. Okay. So I keep telling you that it's a limit range, but I omitted to actually put it into the YAML file. So here you need the kind. So the kind is limit range. Okay. Otherwise the API doesn't know what it is. Now it has been applied to the cluster. What we can do API resources, just to have some information about this resource. Is it namespaced resource or not? Can go range, and it says true. So it's a namespaced resource. Okay, so if you don't put any namespace, it's going to go into the default namespace. It's not a cluster-wise limit range kind of policy. Okay, and that's the one we have here. So I'm going to apply this made by my control resource pod. We're going to describe it. We know that we have set only one 500M on the writer, but let's see what it says. You can see now, even if you have commented out, it has been given those default that you have set in the limit range. 500M for the limit and 500M for the request. So you see, you need to do your limit range the right way, otherwise it's going to be... So here 500 for the CPU, 500, because that's the default that you have put. Okay? You see the default 500M, that's why it has been just going like that. And here the minimum and the maximum will be more an admission door. So this gives from 250 to 1, it's okay. But if I had requested 2, it will just stop it at admission. Okay, probably. That's why I'm going to show you in another way to do it. The other way around, just to see it. Limit range has effect on what. Okay, just here to show you that we didn't set anything. You see those numbers are completely ignored here because we have commented out, but when we have applied this pod, it has been given the default that we have set in the limit range, all the default values. So I'm just going to delete this limit range now. I'm going to delete also the pod that you have deployed. And now we're going to be playing with those numbers. I'm going to go into the pod, activate those CPU limits. Let's see if my cluster can handle that. If it can't, I'm just going to adjust it. So 1 and 2. So 1 request and 2 on limit. So 2 is the max. And at the writer container 501. So from 500 to 1. We apply it. Yes, so it's okay. The cluster accepts those values. We just wait for it to be running. It's running. We describe it just to see if there's no internal issue. Normal, everything is fine. Okay, so we have 2 CPUs has a limit. Request 1 CPU. For the reader, we apply the limit range. We know the limit range is under those limits that you have set in the reader, which is 1 to 2, but the limit range just accepting 1 maximum for CPUs, but here you see it didn't change anything. to the pod. So very important thing to know here. So this policy, the limit range, it has effect only on admission. So on new incoming pod. Okay, not on a running pod. So if you have created this limit range after you created those pods, nothing will be enforced on those. Okay, so we will try to apply to the cluster the same pod now that is deployed and see if it's going to block it or not at admission. Okay, so I'm just going to go into the made.my pod. I'm just going to change the name a little bit. I'll put 2. I'll redeploy it, and after we're going to see made.my controlled resource will be blocked. So it's the same that is already in the cluster. But this one has been created after we have enforced that limit range on the cluster. And now you see, it says it's forbidden. Maximum CPU usage per container is 1, but limit is 2 in your container. So the API request has been blocked with a nice message telling us why. And let me go back into this one, put it back here. I'm going to change the limits. So I'll go back to 500 M for the requests for the reader, 750 M for the limits. So now we are in the range. Might need to put something in terms of name just to change it a bit. Will be accepted. And we apply it, and it has been accepted. Has passed the admission door. Okay? And it's that's the test pod. Okay, I need to delete this pod. We don't need the test pod anymore. So now we get the pods to see that all is running fine. You see? So now we know that limit range is going to be adding those default numbers into the containers of the pods which are created. If they are not set already, if they are set already, it's just going to check if it is in the right range, minimum and maximum. Okay, let's have a break. Please like and subscribe. Congratulations if you have made it this far, but you have even more interesting coming. Limit range, container level, plus pod level. So let me copy this. We're going to use the same, but at the pod level this time, in combination with this container level. And I'm just going to be tweaking this file just to make it compliant to the documentation. So let me go into my normal terminal and delete the limit range that is already there. Okay, this is clean, so that we will be able to deploy this new one. Let's make the name a bit shorter. made.my default CPU container level. And here I'm just going to go 500 M minimum and maximum 500 M. Just gonna go easy on the CPU. And the default 250 M, a quarter of core. So all the containers, they will have to respect that. At the pod level, which is combining all containers that are inside one pod, when you combine all those resources limits, what is the total value? So this is what we're trying to enforce here with this one, which is the pod level. Just change the name. We get the pod level. So at the pod level, we change the type so that it's pod. And here, I might need to delete a lot of those different. So we're just going to be tracking the maximum. Okay. Just let me clean this up, just to be compliant with what is in the documentation. Get rid of my comments. Okay, so the type pod. Max CPU 2. Okay. After, you can also add some other resources. Memory 2GI. I'm not going to touch memory, but I just put it just like that so that you see it. And we're not requesting a lot of memory anyway. But the trigger will be put on the CPU. So let me just change this a bit. I got some trouble because I have a... So let me just readjust that. For sure I did some tests before showing you. And my cluster is crying because I'm watching while I'm making the video. I'm listening to some podcasts. And this is asking more resources from my computer. So we go CPU 250, default CPU 250, max 750. Let's go 500 here. M for the default, 750 for the max, and the minimum 200 for the container. And here for the pod, so that I don't need to create 1,000 pod. I'm just going to be going go one core. And after, we just go back into our pod. We put those requests back to what it was, 500. I'm going to comment it out. Just going to take the default. Okay, so it's just going to take the default here. Let's comment this out. Don't need even to change it. Let's comment this out. Okay, so any pod coming is gonna get the default from the limit range container. So those containers are gonna get those limits. I delete all the resources I did during my test. And now we can go. So we have commented out the pod CPU. Okay, so this is commented out. For it to get those from the limit range. Okay, so all those limits will be given by the limit range, and this policy is going to take care of checking at the pod level after that is not exceeding those limits. Default that you have set up, then we will deploy more pods and see how the limits range at the pod level will stop or not. Maybe we're doing it wrong. Maybe it's not the right way. But you need to watch the video, all the different steps. We'll stop pod scheduling at admission. So let's see what's the behavior of the way we have set the limit range. Okay, so we have always 500M coming in, and we have one core. So 500 is half a core. I think one is too small. Let's go for two cores. So at the pod level, the limit now is 2. The default is still 500. Now, let's apply this limit range, those two limit ranges, container on the pod level. Okay, they've been separated into two. That's what we want. We can check the nodes. We haven't checked. You can see the controller in CPU is at 92%. Okay, memory is 70%. While the worker nodes, they have space and they have capacity, but not that big because they're using 500M. We apply our resource once, okay, all good. You wouldn't have any issue with that. Because this first pod deployment is going to take just the default from the limit range. So I need to maybe declare which pod. Okay, it says 61M for the CPU and the memory 3M. MI. We can describe the pod to see that is if it has those requests on limits. The default, yes, 500 and 500. And we got all the default. Okay, all good. So just don't exceed that. That's all we ask. So now let's create another. We'll just change the name a bit. And after we're going to be tweaking those numbers. Mid MI 2. Okay. I'll just put 2 everywhere. I apply it to the cluster. It's a bit bugging the terminal, but I just tap apply -F, made my controller. Just gonna get the pods. You'll see that it's deployed. Has been deployed successfully. So that's normal. But you see here at top, I don't get all the pods shown. So maybe top is used when you use top pod. Okay, now I get the other one. But it's not correct for the CPU for sure. One of those is saying just 0. That's why it's better to have Prometheus and Grafana setup so that you can have more accurate metrics. This is just something to help very quickly for this video. Or maybe I'm using it the wrong way. I don't know. Okay, so let's keep going and stop focusing on this metrics. But let's just see. Keep going in our examples. We get the pods. Our pods are running. All good. We describe the pod number 2. There's no issues. We get those expected to have CPU default. We go 3. I'm just going to put 3 everywhere as well. So now we feel like we can just deploy as many as we want because we're not exceeding at the pod level, at the container level, those limits, right? Let's apply this one again. It's going to be created. Just tap on the nodes. Okay, the nodes are fine. We just check on the pods. Oh, it's pending. What's happened? Why is it pending? So we at the pod level, there might be an issue. In this namespace, how much are the pods using? Let's just see and describe, no, not this one, the number 3. Okay, let's read. Failed scheduling, default scheduler, insufficient CPU. Node are available 3 preemption victims, found incoming pods, so no. It's not accepting this one. So here it says insufficient CPU. So is it a problem on the node itself? The node is full? Or is it because of the limit range? Let's see. So I just got rid of the limit range that we put on the cluster. I get rid of this number 3 resource that we have deployed that is pending. So I delete it and I'm gonna redeploy it and see if it's gonna be in a pending state. If it is in a pending state, for sure there's an issue with the node. The node don't have CPU resource. Otherwise, it's because of the policy which has been enforced. And you see now container is creating. There's nothing to block it anymore. Because you have to just tell to yourself, we put those limits, but the runtime itself also is going to consume some resources. So that's why we're reaching that limit actually by doing that. Okay. So you've seen this example, amazing. So one pod is using 500 limit as a default for one container. There is 2 containers. So this is 1 giga, 1 G, 1 core, another one, another core, so we reach 2. And when we try to deploy the third pod, so pods are want to eat 3 now, but the limit range at the pod level says 2. That's why it's not going to be deployed. So this is another way to control. Let's have a break. Please like and subscribe during the break. And then let's keep going. Another way to control resources at limits at namespace level, ResourceQuota. So we've seen limit ranges. We've done that. Container, pod level. Now let's go at the namespace level using ResourceQuota. So you have a big namespace. It's spanning across different availability zones because of your cluster having nodes, different centers, but they're all connected thanks to Kubernetes, abstraction of networking. There are resources living in namespaces. And now we're going to see how those limits in those pods. I'm just going to be sending those pods in the cluster. I mean, those containers with one pod. Container is creating. Okay, now it's running. We just waited for it to be ready. We're going to exec into this pod. So the container made by my reader is the first one, which has been described in our YAML file. So that's the one which is going to be default. Just let me open another tab. Okay, so I keep this one in a watch mode just to see if it's going to be still running. We are inside the pod. And let's make this pod move a bit. Let's stress it. If dev0, we write some zeros. Of dev null. So now we're putting stress onto the CPU. I'm going to use 10M. I didn't activate it yet. I just want to show you here everything is running. It's fine. I'm going to try the top just to see if it works with that. What's that? Ah yes, top pod. Okay, one CPU, M. So we need 1000 M to do one core. This is just 1 M. And 4 MI of memory. And just check if there's more options to that. Okay, so it's a utility which is just a very simple one. So we can't use watch. There's no watch for the. I'm just going to be running that several times so that we will see how it's going to grow and change. So I'll just open another terminal, and we're going to be using our watch on the pod from the terminal. And in the other one, we're going to be running the ktop command to see how CPU grows over the time. And this command here is going to put stress on CPU, writing zeros by 10M and 10M. There'll be a little delay before seeing something here growing into the CPU, but this is running crazy here. It's going on in an unlimited way. 90M, you see, now it grows. 498, you see how it has jumped. So we're not going to get the right number straight away, but we will see it growing. 500, so half a core, putting stress on it more and more. Okay, I've been throttled to 500, doesn't go over 500 also. So there's a kind of limit here going on. Is it going to jump? No, 500, okay. It was good to make those experiences and the observations to see how everything works. 5.1, so it's just 500, whatever here we do. Okay. So it has been throttled. I'll run it again, you see, it would have grown normally. This is running fine, without any issues. Hasn't been blocked, hasn't changed the state, so I'm going to stop it. I'm going to stop this. You can breathe. You see how many DI, 255 gigabytes. 500 M, and now it's going to be going down. It's going to be going down slowly. I'm watching, but I don't need to watch, I think. Yes, you see, 326. there's a kind of a grace period. I'm gonna go down slowly, just to be ready to restart if something comes at the right level. So this is a nice behavior to see with this grace period, and now goes back to 0. Cool. Okay, so we didn't put stress on the CPU, so I just wanted to put some stress on it so that we can see how it goes. Okay, so before jumping into the ResourceQuota, I wanted just to show you here that in limit range, when it has those default that we have set at 500, it will just throttle on the CPU, so it won't kill the pod. Pod won't be killed. While in the memory, you've seen that it has been killed. So no jokes with memories. Okay, and here we have deleted this pod. And we go those limits, 500, which have been respected. So we got the limit set as default 500, even if you have set it here max of 750. So I believe that you need to choose which one you want to activate. So if you use default, it's going to be using just the default as a limit on the request. And that's what we've experienced. I'm going to delete this limit range now. I think we've been going through the limit range in all different ways. Now, with this stress test, you've seen what I wanted to show you about it fully. So let me stop the watch. Let me clear this. Here also. And let's go for the topic of this part, which is the quotas, the resource quotas at the namespace level. So as always, I'm going to use a nice sentence to name my file. So quota on namespace resources, just going to open it, and we're going to make it together. So API version 1, kind resource quota, metadata, and we just keep going. We're going to put the name. We're going to name it, stay in the same neighbor, my resource quota. We're going to put it in the same namespace, which is the controlled resources. And here we go and put on the spec what we want to control. So there is this key hard, and after here you can list resources. So here, don't limit yourself in terms of, it's not resource, just request and limits. It's also config maps, secrets, pods. You just put here whatever can be deployed into a namespace. You can list it here. You can go into the documentation to see the list of different resources that you can use here in the ResourceQuota. But that's how I see it. So requests CPU, requests memory, limits CPU, limits memory. We're going to focus on CPU, but I'm just going to put a bunch of those here. This time I'm going to comment those out and keep those into the YAML file, just for you to have an overview of what you could use in this ResourceQuota. Config maps, for example, persistent volume claim that you have seen in the storage video. That was also a pretty complete and long video with some nice experiences. Secrets, you can go also services, and so on. Okay, so let's comment out everything and just focus on limit CPUs. Okay, even not request. We want the ResourceQuota to have an eye and this namespace. We don't want to use more than, and here you say how much CPU. This can be good if you give more freedom to your developers to just do their own deployment in the permitted namespace. But put as an admin some limits in how much resource they can consume with their workload. So here I keep everything small because it's a small cluster and everything. But yeah, you would just do accordingly. So here I'm just going to add a limit on pods. We're going to say 3 pods. So we don't want in controlled resources namespace more than 3 pods running. So if there's more than that, it won't be allowed, it won't be permitted to continue the API requests. So you can also have a scope selector with a match expression. That's how you can play with labels and use this selector for that. I'm going to arrange the indentation that's after. So operator in, scope name, priority class. We're going to see some different concepts here. The scope name, you can't put whatever you want. Priority class is part of what is allowed to put for scope name. Same here, I invite you to go into the Kubernetes documentation to see that. And the values here is low, so a low priority class. Can also have several resources, so resource quotas with different priority classes. Okay. And get pod to be affected to those. So the priority class with the value low, I'm going to be affecting that, referencing that in the pod, and there will be one resource quota having this in place. So get pod to be affected to those pod would use priority class name to reference it. Okay, just put it like that. Comment it out. I just want you to see an extended way. You can use more resource quotas. You can use priority classes. Okay, and those priority classes, you can play with those. In each priority class, there is the different resources that you want limit, and maybe you use the same in different other priority classes, but increasing those. So you're gonna be using maybe high, medium, low, so that you can just say this pod reference priority class name and say, okay, it's gonna be linked to this one. So here we're just going to be focusing on the CPU limits. We want 3 pods max. Very simple. We're not going to overcomplicate, because there's a lot to see around it, and I don't want the video to last for too long. I think 3 hours is fine for this topic. Could be, I think you can make a 10-hour video with that. Limit CPU 1, pod 3. Okay, we don't want more than that. That's what the resource quota is taking care of here. It's just checking those. I got rid of the limit ranges. So let's reset those CPUs. We're just going to manage those to not be, to give us the possibility to actually deploy several ones until we reach the limit. And see what's the behavior of the cluster. So here we are in made.my writer. The CPU requests is at 250 M. So the resource quota doesn't care about that. It cares about the limits on the namespace. So I'm going to apply the quota on the namespace. Okay, 3 pods. And the CPU limit is 1. So I put 1. Yes, it's 1. If it is written 1 is 1, and we're going to see. So here is the example in which I create the resource quota first, and after I apply to the cluster the pod without any type of apply. What's happened? Resource forbidden failed quota. Must specify, you see? I didn't specify any limits CPU. So I just specified the requests, but here it's forcing me. You see, that's how it enforces those rules. It's forcing me to put limits. I got rid of the request. You're going to get that. You see the message, you have to read it carefully and see that it says failed quota, made.my resource quota, must specify limit CPU. And it gives me the names of the containers, so for both containers. So here it's forcing me to put the limit. That's why I didn't comment out first. I wanted you to see that. You can keep the requests, it's fine, no issues, but you must put a limit. There's no choice for that. We have 1 on the reader and we have 500 on the writer. That's 1.5. Okay, so 1.5, it's exceeding, forbidding, exceeding quota. The quota is 1, not 1.5. Okay, limit CPU 1.5. We're at 1,500, while here is just 1. So used 0, limit CPU 1. So it's not going to accept this one here. The admission is just going to block it. So admission checks if there is a limit set. If there's no limit set, you can't go in. If there's a limit set, you need to comply. So that's why I said that this is more enforcing those rules. Okay, so let's go here 250 for the limit. And here the request, we don't care, I just put any number, just lower than the limit. So we have 250, and let's see how much we have in total. I think 750, something like that. Get resource quotas. Yes, it says here 750, and we have 1 pod, so we're good for the moment. So that's why it works fine. Let's see the pod, if it works fine. Yes, it's running. So let me create another one. Just changing the name. I just put 2 here. Don't need to put 2 everywhere. Just here on the top. And let's try to apply this to the cluster. No, sorry. You can't exceed the quota. Okay. 750 already used. 1 is the max. So we're just going to delete. Please like and subscribe during the break. So that was one way we see the resource quota. After this break, we're going to see the other way. I mean the other way. We're going to do it the other way around. Please like and subscribe during the break. Resource quota. Effect on running pods. That's why I say the other way around. Because for the limit range, we've seen the effect on running pods. So here we're just going to K, API resources, kubectl API resources, and see the resource quota. I'm just going to write quota to find it. So it is namespaced, yes. So it's not a cluster wide. We need to namespace it. We get back in our pod that we've been playing with during this video, making it evolve and changing the different settings. Okay, so we have a container made by my reader. We get this volume here. We get the volume down there. Empty dir. Ephemeral-Storage is managing that. Let's put a priority class name here. High or low. Was it low? So I commented out this in the resource quota, but I didn't show you where you're going to put it in the pod. So that's where you put it. You put it at the level of container and volumes, and you put priority class name. And at this time, this, for example, it says low. So here you would go in your node. Instead of high, you would just put low. Okay? Just say low, and that's the value of it. Yes, it's a mess. I use Nano in Vim, that's why. Okay, so that's why you would put it. I'm just going to copy it and put it a little bit on the top so that you can see the levels. It has to be at the container in terms of indentations, container, and so just after the spec. Okay, containers and the volume level. So that's where it goes. It goes like that. So that was one. I wanted to show you where to put it so that it's full. Let's apply it like that to the cluster and see. Hey, for sure it's not going to work because we didn't create any of those. So just comment it out, go through the documentation and see how you set that. So we're not going to focus on that in this video, but at least this is the complete way so that you see. If you have the selector in the ResourceQuota, you get the priority class name in this side. Okay, so here, this has been deployed. What is consuming? The limits. We focus on the limit 250. This is the writer container. And the limit here, 500 for the reader. So we have 750 for the pod overall in terms of limits. 500 plus 250. Okay? 500 here and 250. Okay. This. Now you got it. You know where to look at when you're describing those pods. Let me nano first. Let me go inside this one here. I'm going to deploy another one. 2. Okay, let's put 2 everywhere this time. You don't need to put 2 everywhere. So my terminal is bugging again. Let me just apply this. For sure, it won't accept because we're going over. Exceed the quota. So I need to maybe get rid of this quota. Okay. Because I want to see the effect of it on running pods. So now we have 750 plus 750, 500. So 1 core and a half. And now the number 3 is going to add 750 to it, which is going to be a 250. So 2 cores and 1/4. Just we make sure that we exceed the limit like crazy and see what is going to happen. Okay, we get the pods. I have deployed it. We have everything running. Let's see if the K-top works for that. Not sure. In the namespace, I'll just try. Yes, it works just for node and pod. Node and pod. Nothing to explore here. K-top pod. Controlled sources. Okay, so unless what I've seen since the beginning of the video, unless you specify one single pod, you won't get any metrics from it. For the CPU, it just says 0. So we don't care about that. We know that you have exceeded the limit, which is 1 CPU, 3 pods also. We already reached it. There is 3 pods, but the limit in terms of CPUs has been exceeded by far. because we have double, we have 2.25, so 2.2, 2.25. And now we're going to apply this quota and check. What does it say here in terms of metrics? It says 3 of 3 pods, and it says 250 M. So we exceeded the limit. Here, it just says what is observing from the cluster, but it can't enforce anything on running pods. So everything works at admission. That's the door. That's what you need to know about that. So if you get any issue in the cluster and one of those pods try to restart, it won't be able to run again. That's why you need to know what's the behavior also of this ResourceQuota. Because part of the promises of Kubernetes is that when a pod dies, there's some mechanism to have this availability, so it's going to be able to restart, right? So less downtime, more availability, happy customers. So you're going to just delete everything, so it doesn't have any effect on running pods. But when you have running pods and it exceeds the limit, you see, as I'm going down, just deleting those pods, we can see now that limit going down, and I'm trying to reapply this to the cluster. We're still above. Okay, what is used is 1,500. The requested is 750 and the limit is 1, so we can't go over. So now you got it now. So let's tear down everything. Congratulations. We have seen how to set requests and limits of resources. We have tackled the MTDR issue and have seen the contingencies that could be used. Limit range has been nice to see, as it filters at admission resources and provides default requests and limits, but ResourceQuota is the one that could enforce resource restrictions. After playing with toleration, tent, selector, labels, in combination of those resources filter and or control strategies, you can have a very fine-grained hand on the cluster at different levels, so container, pod, and namespace. That is why in next video we are going to do the transition by seeing more admission controls and advanced topic that not many understand actually. So be ready. Okay, let's stop here. Hope that you like this video. Please like and subscribe, and see you next time.